Hi everyone, we're going to be looking at malloc and calloc again. We'll do a live coding example. I also want to point out that this is going to be in, I think it's lecture 11. It's the strings lecture, live lecture. That again, I give you access to the code repository where all of the lecture content is going to be. So yes, lecture 11 string test. But we're not going to necessarily just do string tests. So let's have a look at what we have here. I'm going to do a couple things. So here is my main method that we looked at before. Fine. I just commented out the scanf and printfs for the short message. Fine. Let's look at malloc and calloc. So here is, I'm going to make an array of 20 characters, character array of 20, size 20. So size of character multiplied by 20. And then I'm going to, I'm going to cast it to a character pointer. And this is going to be my array. Now, once I have that, I can use my array to my heart's content. But you'll notice one other little gotcha in here. What I also want to do after I call malloc or calloc is I want to make sure I got a pointer. If this is too big, 20 bytes should not be too. 20 bytes of memory should not be too big. But if it doesn't successfully work, this will be null. So I want to check to see if it's null or not. So as long as it's not null, now I can use this. So I'm going to use one of our built-in functions called string copy, or one of our string functions, string copy. I'm going to copy over. This is me copying a string over to my array. This is when we had an example earlier with structs. I said, this is technically not right. You can't just, set some value here. If I make an array of characters, I can't just say it's equal to this message. It doesn't work that way. It'll actually it'll change the pointer on me. What I really need is, if I want to put it into this buffer, I need to copy over the characters from one array to another. This is what the string copy function is going to do. It is going to copy this string here, over into this string right here. It doesn't change what I'm pointing to. It moves all of this text, it copies this text over here. It's like Xeroxing it. Okay. So I'm going to make an array. I'm going to put this text in this array, and then I'm going to print off the message. Something bad's going to happen, by the way, just letting you know in advance. Sometimes I like having it as a surprise. Sometimes I don't. I'm not going to have it as a surprise this time. And then I'm going to free my array after I'm done. And again, every single time I free my array, and I'm almost going to put another error in here. Once I've freed my array, and let's put a breakpoint. Once I've freed my array, I want to set it to null. If I don't set it to null, weird things are going to happen. Okay, actually, let's do that. So we'll do two different things first. First of all, I'm going to run my code. It should barf on me somewhere around here. There we go. Retry. What happened here? Oh, wait. I triggered a breakpoint. What's the breakpoint? Well, string copy used to not have this _s. String copy used to say, take this string, put it in this string. How long are the strings? I don't know. I don't care. Right. And so if your string was too long, it would merrily go fill up the destination buffer. It used to fill up this destination buffer and just keep going and stomping on random memory afterwards. Again, as you might imagine, that's bad. So if you have this, what you want to do is you want to find your bug immediately. In this case, my string is too long. It's greater than 19 characters. I could actually check this if I wanted to make sure. So I could have something like, let's make a constant char star a source is equal to this. So what could I have done here? I could say, I need a semicolon at the end. Int, let's do just an assert. Assert a source, and I'm going to also make another constant variable here. So constant int char buff size is equal to 20. All right. instead of hard coding numbers, because just in case I forget one of the 20s, I want to just use this everywhere. strlen. I could do something like this. I have to say it's less. It must be strictly less than the size of my character buffer. It's not going to be. I'm going to have an assertion error right here, and then I'm going to have, just to be on the safe side, and I'm going to copy over that string from one to the other. And I'm going to also move this up here just so I know what's going to happen. Because this message right here, I could copy, just not the whole thing. This message is going to be too long when I'm done with it. Okay, so let's compile it again. I no longer have just these hard-coded 20s everywhere. I'm just going to use char buff size, and I can just access this. Let's make sure it's all well and good. Okay, so let's run it and see what happens. All right, another error. So what is the length of my string? Oh, there he goes. This is where my error is. It's right in my assert, right where I would hope it would be, and I can sort of deduce what's going on with my program right away. Another case of I want to find the bugs or the problems before I do something else. This happens to set off an assertion right here as well, because I'm using this new _s function. If I just did string copy without the _s, the old way of doing it, it would merely let me go past the length of my buffer. And so I would want one of these assertions just to make sure everything's fine. It doesn't get into production code, it's just stopping it early on. Okay, but I know that that's going to be a problem. So let's actually, copying, I know that this was going to be the part of the issue here. So this is me copying. All right. That's why I have this comment up here, the way that it looked. All right. I'm going to run it again. I know my message is too long. So let's stop it. Let's see what happens. All right. And do I keep going? Yeah, I get to my breakpoint. So the string length was fine. This length of string here was fine. The copying was fine. A-text4 is actually this is me copying is the name, is what the text says right here. Great. So the string copy function actually worked. I put this message from a source into text4 just fine. Next step, I'm going to print off my message, and then I'm going to free my array. My array, a-text is still pointing to the same address it was pointing to before. But now I got a bunch of gobbledygook in here. That would be fine, but I'm still, it's not that fine. I'm still pointing to an array that is no longer under my control. And so if I go one step further, it should blow up yet again. Oh, no, it doesn't. Wow. YYC, I just stomped on some random data that could be used by some other part of my system. See that right here? I stomped on this thing. I put the C in here. It's not mine to control anymore. I've given back the library. I can't even think of a good example of this. Oh, I gave the house example. I went back, I sold my house, and then went back and started stealing stuff from them, right? Or started doing stuff. I started doing renovations around my old house. That's not, you do not want this. This is a big, big no-no. This is terrible, because you'll never find the error. It'll be somewhere else with multiple threads, and you won't be able to know why randomly your array is changing on you and you don't know why. So let's stop one more time. I'm going to put this back in. I'll actually break it again, but this time it'll actually break properly. It's going to explode on me, and then we're going to make sure it's fine. So now it's going to explode on me. I'm going to get to a null, and now I have a null pointer exception. I'm not stomping on some random data. It is, this thing is null, and I'm trying to put a C into null, and it explodes. You can't do that. It's pointing to nothing. What am I going to change? I get a null pointer exception, and that's what I want. When I set it to null, it prevents me from accidentally stomping on a C in memory that I no longer control. So I can then go, oh no, I should have that commented out, and I'm good to go. Next step, I'm going to make an array without, we're going to go through here. I'm going to make an array. I'm going to ask the user for the size of the array. So the number array size, I'm going to set to 0 at first, but write the size of the new array that I want. And so my scanf is going to take in an unsigned integer. That's what the u is. I'm going to put it into this right here, this variable right here. It has a grand total of one thing in it. And then afterwards, I'm going to call malloc, and I'm going to use that size. So whatever size array I want, this thing will make an array of that number of integers. So if I say it's 80, I'm going to make an array of 80 integers. I then need to, I'll get my array. I need to check to make sure that the array is valid or not. If it was null, I don't go into this if function, this if statement. If it's not null, it means I successfully got memory. And then what I'm going to do, just for fun, is I'm going to print off whatever garbage was in malloc. Now, I'm not sure it's going to give me garbage. It might automatically clear my array in debug mode, but just in case, let's find out. Okay. And then we're going to look at it using calloc. So, is it up to date? Okay. Size of the new array. I said 80, right? So make an array of size 80. And I stopped at my hello world. All right. This is what was in my array when it started. I think there was those CCCCCs. It gave a standard starting value to them. Not useful, but at least allows me to know that I didn't initialize things. Okay, so that's a little odd. And by the way, I did, again, free up my memory, and I set it to null afterwards, just to make sure everything was fine. Okay, I'm going to do one more thing. So that's also make sure that if I use a num test down here, it's going to be null no matter what after I'm done with this. So I've got a null pointer exception. So let's do one more thing with this. So this is, when I walk through this thing, it's going to give me a bunch of garbage, whatever was in malloc beforehand. I'm going to try the calloc version of this. So same thing, same array size. I'm just using calloc instead. So instead of doing this multiplies, I say the size of an integer, and then I say the size of the array that I want to make. And then I cast it to be an integer array. Okay, let's see it in action, hopefully. And we'll make it 80 again, just to keep it consistent. And I hit my breakpoint later on, and zeros. It zeroed everything out for me. Calloc cleans things up. So there is an example of calloc in use, malloc in use, free in use. I use free as well. I set things to null, and we even dealt with copying text from one array to another. It's from one character string to another using string copy. Okay, hopefully that example makes a lot of sense, because what we're going to do now is we're in memory. Here's calloc. I would like you to take this quiz. So here is what the quiz question is going to be. You should be able to, it should be available to you online right now in Poll Everywhere. If I made an array, a dynamic array of pixels, what would it look like? You should not need to pull up the pixel structure that we talked about in previous lectures or anything like that. Everything you need for this answer is in the question right there. So what would a call to malloc be for the pixel structure? So with that, we're going to stop it. And then we're going to look at pointers next. It's going to be a whole new world, so it's got a lot of fun. So try the quiz, and we'll get to pointers next.